Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson, I will explain examination questions from previous matric exam papers which you can use as part of your exam preparation. This is lesson 8 of 11. Example 1. In the figure, DE is parallel to FG is parallel to BC. AD is 36 centimeters, DF is 24, AE is 48, and DE is equal to GC is equal to 40. Determine with reasons the lengths of EG and BC. Now let's start with EG. We can start by saying EG over AE is equal to DF over AD. And the reason is line parallel one side of a triangle divides the other sides proportionally. And then we can substitute. EG is what we're looking for. AE was 48 equals DF is 24 and AD is 36. And now we will multiply away the 48 and EG is 32. And we can fill it in. Then we also want BC. Now do you agree that triangle ABC, the big triangle, is indeed similar to triangle ADE? That's the little triangle on top there. And the reason why we can say that is because they are equiangular. And then if you go to the triangle, you can see that angle A is the common angle, and then D will be equal to B, corresponding angles, and angle E is equal to C. They are also corresponding angles. Therefore, the two triangles are similar. They are equiangular. Then we can say, since they are similar, we can say that AB over AD, the ratio, is equal to BC over DE is equal to AC over AE. And the reason why we can say that is because the two triangles are similar. Then we want BC. Therefore, we will use those two ratios. BC over DE equals AC over AE. This one by for now. And we substitute. BC is what we are looking for. DE is 40 equals. AC is that whole length, and it consists of AE, which is 48, plus EG, which is 32, plus GC, which is 40, over AE is 48. And then we can multiply away the 40, and we end with BC is equal to 100. Example 2. In the diagram, DA is a tangent to the circle ACBT at A. CT and AD are produced to meet at P. BT is produced to cut PA at D. AC, CB, AB and AT are joined. AC is parallel to BD. Let A1 be equal to X. Number 1. Prove that triangle ABC, that's the green triangle, is similar to triangle ADT, that's the blue triangle. Now, before we start, we can say that A1 is equal to B2. And the reason is that's the tan-chord theorem. The angle between the tangent and the chord is equal to the angle in the opposite segment. Then we can also say that B2 is equal to A3. and the reason is they form alternate angles because AC is parallel to BD. Then they are both equal to B2, therefore we can say that A1 is equal to A3. Now we can start by saying, in blue triangle ATD and green triangle ACB, A1 is equal to A3, that was proven above. Then we can say T3, which is this angle, is equal to angle C, and the reason is exterior angle of a cyclic quad is equal to the opposite interior angle. And then the third angle, D1, is equal to B1, third angle of a triangle. Therefore, triangle ATD is similar to triangle ACB, and the reason they are equiangular. Question 2 says, prove that PT, that red line, is a tangent to the circle ADT at T. Now, where's that circle? It's not there. It's invisible. So there you find this invisible circle, and we have to prove that TP is a tangent to that circle. Now, T1 is equal to A3, and the reason is they are angles in the same segment, and it's chord CB that subtends them. We know that T4 is equal to T1 since they are vertically opposite, and then you can see they are both equal to T1, therefore T4 is equal to A1. Therefore, PT is indeed a tangent to the circle, and your reason is, if an angle between the line and the chord is equal to the angle in the opposite segment, then the line is a tangent. Question 3. Prove that triangle APT, that's the green triangle, is similar to triangle TPD, that's the red triangle. Now we can say that angle P is the common angle, and then we actually only have to look for one other angle, and this was already there, that angle A1 is equal to angle T4, already proven they are both equal to x. And then without thinking, we can say the remaining angle ATP is equal to angle D2, and your reason, third angle of a triangle. And then, therefore, triangle PAT is similar to triangle PTD, and the reason, angle, angle, angle. Before we continue, have you subscribed yet? And a reminder, you can also visit my website, onlinemaths.co.za. There you will find all the chapters in the syllabus. Also, feel free to leave a comment or like my video. Let's continue. Question 4 says, if AD is equal to 2 over 3 AP, show that AP squared is equal to 3PT squared. Now, in the previous sum, we decided that triangle PAT was similar to triangle PTD because they were equiangular. Now we can say the ratios PA over PT is equal to AT over TD is equal to PT over PD because the triangles are similar. Now let's see. Do you agree what we are looking for is AP squared and PT? Now we go to the ratios. Well, there's a PA or a AP, there's a PT, and there's a PT. So then this one is by for now. And then we can cross multiply. And remember, PT times PT is PT squared equals PA times PD. Now, let's zoom in on PD. First of all, do you agree what was given was that AD is equal to 2 over 3 AP? Now, you can divide with AP and then you end with AD over AP is equal to 2 over 3, the ratio. Now, when you go to the sketch, it's this. AD over AP is 2 to 3. And then do you agree DP will be 1? So therefore, we can now say the ratio DP over AP is equal to 1 to 3. And then we can make dP the subject of the formula, so we will multiply the AP both sides. Therefore, dP is a third AP. And then when we go back to our sum, there's PD or dP, so in dP's place we substitute a third AP. And then we can say PA times AP, it's the same thing, is AP squared. And then to get rid of the third, we multiply both sides by 3. And therefore, 3PT squared is equal to AP squared. In the next lesson, I will discuss even more examination questions from previous matric exam papers, which you can use as part of your exam preparation. Click on the video in the left-hand corner to take you straight to the next lesson.